Hello students, I am Mr. Adinath D. Badar, Assistant Professor, Department of Chemistry, late Pushpadevi Patil, Arts and Science College, Risod, Dist, Washington. In this video lecture, I am going to discuss the topic that is nomenclature of coordination compound. Nomenclature of coordination compound. So, in order to assign the name of any complex compound, firstly necessary for us to know its formula. Hence, the systematic nomenclature of complex involve two different aspects. That is, first aspect is writing the formula of coordination compound, and after that writing the name of coordination compound. International Union of Pure Applied Chemistry, that is IUPAC, revise time to time rules of nomenclature. Now, firstly, we see how to write formula or writing the formula of coordination compound. So, first rule is in the formula symbol of central metal ion is written first followed by the ligand. For example, these are the complex compound. Here, first we need or we must write a central metal ion followed by the ligand. Another rule is the order of listing the ligand is firstly we have to write anionic ligand, then secondly neutral ligand, and lastly cationic ligand. Now the third rule is if there are more than one ligands of any type, say anionic, they are listed in alphabetical order according to the first symbol of their formula and not according to first letters of their name. Now the fourth rule is the polyatomic ligands are written in parentheses. For example, complex containing one cobalt ion and chlorine, bromine, iodine and 3 mole of ammonia as ligand will be represented by the formula writing first cobalt, then bromine, then chlorine, then iodine, and inside the bracket 3 mole of ammonia. For complicated organic ligand, their commonly accepted abbreviations are used. For example, for the ethylene diamine, simply EN symbol is or abbreviation is used. Like pyridine, PY's abbreviation is always used. Their place are decided by first symbol of their formula in the formula and not by the first letter of their common name. These abbreviations are also placed in parentheses or inside the square bracket. The whole formula of coordination sphere is enclosed in square bracket. Here, for example, the whole formula is enclosed in a whole square bracket. The oxidation state of metal is written as a superscript in Roman number. The charge on the coordination sphere is written outside the square bracket as superscript, in which the number is written before the sign of the charge. Now the next rule is, now the student should note that the procedure of writing the formula of coordination complex is completely different from the procedure of naming it or vice versa. This would be clear from the following discussion, that is writing the name of coordination compound. Now next we will see how to write name of complex, how nomenclature or how to write name of coordination compound. So firstly, order of naming ion. If the compound is ionic, the name of cation is mentioned first followed by the name of anion. For example, Here these are the cation. So firstly we write potassium. After that name of ligand. After that name of ligand. For example, in this complex here potassium hexacyanoferrate. Here potassium might is cationic. Then we have to write potassium. After that the anionic moiety is cyanide. These are the six. Then hexacyano, and these are the metal ion. Now naming the coordination pair. In naming the coordination pair, whether it is constituted by cation, anion or neutral molecule, the ligand are named first, followed by the name of metal ion. The oxidation number of metal ion is expressed by Roman number in parentheses just after that the central metal ion, that is in sequence as firstly we have to write name of ligand, that is hexacyano. After that we have to name central metal ion, that is ferrate, and these are the oxidation state of iron or Fe, right inside the bracket. After that central metal ion. Now next naming the ligand. The central metal ion in complex is surrounded by negative, positive or neutral ligand. For the ligand carrying negative charge, for the ligand carrying negative charge, the name has a characteristic ending word by using O. Firstly, we see the rules for central or complex or coordination pair. If the coordination entity is either neutral, cationic, then usual name of the metal is used. But when the coordination entity is an anion, then name of metal end with the suffix ate. Here example, for example, lithium hydridoaluminate. Third, here lithium, that is the cationic species, we must write lithium first. These are the square moiety or inside the square moiety. Firstly, we need to write ligand, that is hydrido. After that, the central metal ion, that is aluminate, and the complex is negative or anionic. Then the name of metal or central metal ion is ended by using ate. After that, these are the oxidation state of this aluminium, and write inside a bracket or parenthesis. Now the second example is Na3CONO2 6. These are also negative complex. So firstly we need to write cationic species, that is sodium. This sodium. After that ligand hexanitrito N cobaltate ATE. These are the anionic complex. Another next example, diamine silver first nitrate. Here no cationic species are present in this complex. Then we start name by using a ligand. For example, these are two amine, then diamine silver first nitrate. These are also anionic complex. Then the silver ended or silver name ended by using ATE, that is nitrate. Another example, these are the potassium tetracyano aerate third ion. Potassium, first we have to write potassium, that is cationic species. Tetra cyano, these are the four cyanide. Then tetracyano, these are the gold, that is aerate third ion. Another example, nickel tetracyanide or tetracyanonickelate second ion. Here also no cationic species are present. Then we have to write name by using first ligand, that is tetracyanonickelate, second ion, tetracyanonickelate second ion. Now the next topic is isomerism in coordination compound. So the two or more chemical compounds. So firstly we see what is the isomerism. What is meant by isomerism? So simple definition is if two or more chemical compounds with identical chemical formula but different structure are called isomers, and the phenomenon is known as isomerism. Hence isomers have different physical and chemical properties. Coordination compounds gives rise to wide variety of isomers due to different structural arrangement of the constituent atom. Isomerism in coordination compound may be divided into two main types, that is stereoisomerism and structural isomerism. These stereoisomers are further divided into two types, that is geometrical isomerism and optical isomerism. These structural isomerism are further divided into main four types, that is linkage isomerism, ionization isomerism, coordination isomerism, and solvated or hydrated isomerism. So firstly we see what is the meaning of geometrical isomerism. Geometrical isomerism, these are the stereoisomer. These isomer contain same atom and the same atom to atom bonding but different only in the special arrangement of atom or group about the central metal ion. It is possible only in the complex with the coordination number of 4 or greater than 4. These are two types. So first type is geometrical isomerism and second type is optical isomerism. So firstly we discuss the geometrical isomerism. This type of isomerism arises in coordination compounds due to the difference in geometrical position, that is arrangement of ligand around the central metal ion. If the same kind of ligands occupy position adjacent to each other, it is called cis. For example, this B and this B, this A and this A are same. So this type of arrangement is called cis configuration, and if they are opposite to each other, for example this A are opposite to this A and this B are opposite to this B, then it is called trans configuration or transform. Thus this kind of isomerism is also referred to cis trans isomerism. It is very common in coordination complexes with coordination number 4 and 6. It is not possible for complexes having coordination number 2 and 3 because in these complexes all the positions are adjacent to one another. Here these are the example of cis and trans isomerism. These are, for example, this complex, this chlorine are opposite to each other, and these amine are also opposite to each other. Then this form is called as trans or transplatin. And here this chlorine and this chlorine are adjacent to each other. Also these amine and these amine are adjacent to each other. Then this form is called as cis, and this is the cisplatin. Example of cisplatin.